Hi, everybody. It's Professor Mitchell, continuing with Chapter 5. In this video, we'll look at Section 5.4 on the multiplication principle. In this section, we'll look at tree diagrams, the multiplication principle, and then the generalized multiplication principle. A tree diagram is a graph showing possibilities for an event having choices along the way. Suppose a rat in a maze starts at point A. There are 5 possible routes to get from point A to point B, and 3 possible routes to get from point B to the final destination, point C. Let's represent the possible choices using a tree diagram. All right, so the tree diagram might look something like this. Here is point A, where the rat starts. The rat can choose any one of 5 paths to point B. And then regardless of which path was chosen to point B, there are 3 different paths from point B to point C. So here is a list of all the possible paths. And as you can see, there are 15 of them. So we can also solve this problem using the multiplication principle. It says, suppose that a task is composed of 2 consecutive choices. If choice 1 can be performed in m ways, and for each of these, choice 2 can be performed in n ways, then the complete task can be performed in m times n ways. So now let's use the multiplication principle to determine the number of different paths a rat can take going from point A to point C if there are 5 possible routes to get from point A to point B and 3 possible routes to get from point B to point C. Since there are 5 possible routes for task 1 and 3 possible routes for task 2, there are 5 times 3 equals 15 possible routes, which agrees with the tree diagram drawn previously. And that brings us to the generalized multiplication principle. So the gist of what this says is that it works on tasks that have more than 2 steps to them. Suppose that a task consists of t choices. So in the version we just looked at, t was 2, performed consecutively. Suppose that choice 1 can be performed in m sub 1 ways, and for each of these, choice 2 in m sub 2 ways, for each of these, choice 3 in m sub 3 ways, and so forth. Then the task can be performed in m1 times m2 times m3, multiply all those numbers together all the way up to m sub t ways. So the classic old tired cliche example that I often use is, suppose that I've just done my laundry and I'm getting dressed for work and I have 5 clean shirts, 4 clean pairs of pants, and 3 clean pairs of socks. And the question is, how many different outfits can I make out of those shirts, pants, and socks? Well, since I have 5 shirts, 4 pairs of pants, and 3 pairs of socks, I can put those together in 5 times 4 times 3 different ways, which comes out to 60. Another example, a corporation has a board of directors consisting of 10 members. The board must select from among its members a chairperson, a vice chairperson, and a secretary. In how many ways can this be done? So at this point, you might want to pause the video, think about this, and then come back when you think you have the answer, which I will go over with you now. So the operations are, first select a chairperson. There are 10 ways to do this because you have 10 people to pick from. Then when you select the vice chairperson, there are 9 ways to do this because you can choose any person other than the person who's already been selected chairperson. And finally, to select a secretary, there are 8 choices because 2 people are already serving as chairperson and vice chairperson. Therefore, the total number of ways to complete this task is 10 times 9 times 8, which is 720. And coming up in, I believe, the next section, we will talk about a slightly different way to do this problem. In the meantime, that's going to do it for section 5.4. The multiplication principle states that the number of ways a sequence of several independent operations can be performed is the product of the number of ways each individual operation can be performed. And that's going to do it. We'll see you next time.